Let's continue now with the other cortices in the brain and where they're located. So the somatosensory cortex is located in the parietal lobe, again, right and left. And it is located on the post-central gyrus of the parietal lobes. So, and again, right and left. So again, if I ask what's this bulge or what's this raised area called, you would say post-central gyrus. If I said what's this cortex called, you would say primary somatosensory cortex. Somato is the same root as comes from soma, body. So this is going to receive sensory information from the body. Touch, pressure, temperature, pain, all of those things that we think of as our sense of touch, these are going to come into this section. Now, this is not going to be vision, smell, hearing. Those are going to be handled somewhere else. So this is the somatosensory cortex. It is going to coordinate through the somatosensory association area, which is located still on the parietal cortex, parietal lobe, but just posterior to the somatosensory cortex. So again, we have this cortex and association area, the cortex receiving the information, and then the association area processing and integrating that information. So I want to introduce you to this thing called a homunculus. The plural is homunculi. And we have these with both the motor cortex and the somatosensory cortex. And that is that each section of the cortex is dedicated to a specific part of the body. So the homunculus, the word homunculus, means sort of human-like. And so a homunculus is any kind of either diagram or creature that looks like a really weird human. So here we have on the motor cortex, this is showing the right motor cortex, we can diagram each section here that is dedicated to the muscle specific to a certain spot on the body. So this little area right here, right above the lateral sulcus, is dedicated to the pharynx and then the tongue. The tongue has a really big area because there it is all muscle. And we can make this sort of weird looking diagram of a human, okay? That's a homunculus. Now, at the same time, on the somatosensory cortex, here we have the right somatosensory cortex, we have different areas dedicated to receiving sensory information from specific parts of the body. So again, we see larger sections where we have lots of sensory information or sensory receptors. Notice, though, that the area for the tongue is smaller on the somatosensory homunculus than it is on the motor homunculus, because we have lots and lots of muscles to control, but not as much sensory information for touch and heat and texture. We have lots of taste receptors, but those are going to go to a different cortex on the brain. So that's what the homunculus is. Now, these are very important. Say if someone has a brain tumor, we can actually start to figure out, even before we do a CT scan, where it might be based on where they have either muscle twitches, if it's in the motor cortex, or if they have numbness or pain, if it's in the somatosensory cortex. If doctors are trying to remove a tumor, then when they touch these parts of the brain, they can make the person feel in these specific parts of the body, which is bizarre. All right, so we talked about the frontal lobe. We had the primary motor cortex and the motor association area. This is, remember, the precentral gyrus, the central sulcus, and then the postcentral gyrus, which houses the primary somatosensory cortex. And then behind that, the somatosensory association area, which takes up the rest of the parietal lobe. So now we have some more cortices, and let's work our way through these. Oh, before we get to those, let's talk about a couple functional areas. These are not actually cortices. Cortices is plural of cortex. These are just areas around other cortices that control specific things. And both of these, it turns out, are on the left hemisphere. There's not a coordinating area on the right hemisphere. The motor speech area, also called the Broca area, is here kind of between the frontal and parietal, mostly on the frontal lobe. It is responsible for controlling the muscular movements that you need to speak. So someone who has damage to Broca's area will know exactly what they want to say. They understand everything being said to them. They know what they want to say, but they can't make the word. Wernicke area is responsible for recognizing and comprehending language in its written and spoken form. So this is kind of between the parietal and occipital lobe back here. A person who has damage on the Wernicke area, they may not understand what's being said to them, or they might understand and not be able to put together sentences in an understandable fashion. Their syntax and word order is going to be messed up. They're going to choose the wrong word. They're not going to have any trouble making those sounds, but they are going to have trouble choosing the right word and putting the words together in order. So later on in this Canvas module, I have videos of people with Broca aphasia, meaning damage to the Broca's area, and Wernicke's aphasia, damage to the Wernicke area. So you can see the differences in those two. Oddly enough, and this I think is so cool, neither of these has any effect on singing or the ability to understand sung language. Singing is a completely different set of brain control, and it's in the right hemisphere. It's on the temporal lobe of the right hemisphere. How weird is that? All right, now other cortices that you need to know. These are all very small. The olfactory cortex processes smell. Olfaction means smell. That one is right here at the tip of the temporal lobe. The auditory cortex is here, also on the temporal lobe. It's going to process sound. The gustatory cortex is on the insula, so it's deep to these two, and it's going to process taste. Okay, so gustation means taste, auditory means sound, olfactory means smell, and then there's one other, the vestibular cortex. It's kind of next to the auditory cortex, and that one processes in specifically balance, and we'll come back to that when we talk about the ear. We'll talk about the vestibular control more in detail. Now the visual cortex is located on the occipital lobe. Okay, so back here at the most posterior part of the brain, you have the visual cortex. Now remember that the eyes are up here on the front. Okay, so these signals, they have to go through, they're going to synapse a few times, it's kind of a complicated pathway to get to the cortex, and then the cortex integrates with the visual association area to make sense of what is seen. There is a region in the visual association area that makes sense of the various shapes and colors and makes them into a face. If you have damage or undeveloped or any problem with that area of your brain, then you're not good at recognizing faces. And you can actually be face blind, which means that you don't recognize faces. You might still recognize someone by the way they walk, by their hair, by their voice, but you don't recognize faces. That is a very specific and bizarre thing. I think I have a little of it because I'm so bad with faces. People who can remember faces just blow my mind. All right, so let's review all of this. We've got our frontal lobe, primary motor cortex, premotor cortex or motor association area, somatosensory cortex, somatosensory association area, visual cortex, visual association area, those make up the occipital lobe. On the temporal lobe, we have the auditory cortex here, the olfactory cortex, and then we have the gustatory cortex on the insula. Okay. And those are all of our cortices that I need you to know on the brain. And we also have right here the Broca's or motor speech area, and back here the Wernicke area.